So today's learning target, we are going to use ratios to solve for missing sides of similar figures and write similarity statements. I'll give you a little warning before we get started here, okay? The stuff that we're gonna kind of ramp up as we go along today. So I'm going to show you some new stuff, and it's going to seem really simple at first, and it is actually quite simple. It's simple to understand, but it's also simple to make mistakes. It's one of those things. Easy to do, but easy to screw up. Okay, so I'll show you, and you're going to be very confident, but you are going to find yourself making mistakes. So just know that going into it. What we're going to do today is not terribly difficult, but I need you to look for some strategies that you can use that you know are going to work for you to avoid mistakes. Okay, so things that I do to avoid mistakes is try and get into a habit of always checking my work when I get to certain steps where I tend to make mistakes. And I'll point out where I find the mistakes happen for me and my students as we go through. And then just double checking my work when I finish up. And a lot of the simple mistakes happen around these similarity statements, but we'll get to that a little bit later. We're going to start off kind of reviewing what we've done before. So remember, our last learning target was identify similarity. And I'm going to give you a problem. This is based on one out of the book, but I'm going to modify it a little bit. So you don't need to worry about opening your book up just yet. Just go ahead and sketch this for me. We've got a couple of rectangles. One's a little bit smaller than the other one. And I just want to review what we did last time because it's been a while. This was like over a week ago. And there's been a lot of, at least for me, a lot of turkey gravy and stuffing and mashed potatoes in between. That tends to make my brain a little soft. So we'll dust off some cobwebs here. When we were talking about similarity last week, we said that similar figures had to have two things. They had to have, all their angles had to be equal. So matching angles have to be equal. And all of the sides have to be, do you guys remember what the other one was? It was on that page we were just looking. Not similar. The figures are similar. What about the lengths? The lengths must be in proportion. Good. In proportion, which means we need to be able to write fractions for all the matching sides and show that those fractions are all equal to each other. Now, technically, you got to do this for every single angle and every single side. So if I'm looking at two rectangles, there are 8 different things that I got to check. Right? Because there's 4 sides and 4 angles. Now, luckily in this problem, the angles are going to be pretty easy because, like, oh, look, those are both 90, and these are both 90, and these are both 90, and these are both 90, right? So I didn't have to really do anything fancy there. But technically, I should be writing ratios for 4 sets of sides because there are 4 sides here. Other nice thing about a rectangle, though, is that opposite sides are equal. Agreed? So that's also a 6, and that's also a 2. This is also a 21, and this is also a 7, which means when I write these fractions, 2 of them are going to be exactly the same, and the other 2 are going to be exactly the same. But I'm going to go ahead and write all 4 of them down because technically that's what we have to do to show that 2 things are similar. All right, so I'm going to make a fraction out of, I'm going to go with the 7 and the 2 first. Now remember, the tricky thing about this is being consistent. Do we want to do the 7 on top or the 2 on top? There's no wrong answer here. You want to do the 7 on top? 7 on top? Agreed? All right, we'll do the 7 on top. So we're choosing to put the bigger shape on top. Big shape goes on top, small shape goes on the bottom. Let's be consistent with that when we do the rest of it. So I got 7 and 2 from this one. And I know I got another 7 and 2, right? So let's go ahead and put that right next to it since it's exactly the same. And then we got to do the top and the bottom. So 6 and 21, right? Like this, right? Like that? Is it like that? Or did I make a mistake? Oh, I'm sorry. I flipped them. We said we were going to put the big one on the top. Let me fix this. Gotta watch that one. That's where things are going to go wrong when you start flipping fractions. Okay. And then the bottom's also 21 and 6. This time I'll get it right. Big one on top, small one on the bottom. Now, I know that these two fractions are equal, and I know that these two are equal, but are they all 4 equal to each other? Think about 21 and 6. What number could I divide both 21 and 6 by? They both divide by 3, don't they? And if I do that, 21 divided by 3 is 7, and 6 divided by 3 is 2, and oh, it looks like those fractions are all the same. They're all equal to 7 over 2. This one's also equal to 7 over 2. Which means that all sides, and please write this out, all sides are, remind me what the in proportion, thank you. When I say they're in proportion, that means that the angles that the sides make the same fraction. So all the sides are in proportion and all the angles match. And when I combine those two facts together, that tells me what? That means they are similar. Definition. Hey, how you doing? Nate. No. I don't. Nate? Yes, I'm sorry. Yeah. But he's not here. Okay, thank you. Sorry. Sorry. Still learning names. Okay. So if they're all in proportion and the angles match, that means that they are similar. So they are similar. Do you remember the symbol for similar so we don't have to write it out? Don't you? That's congruent. Similar, and I love that you remember that. Similar is just the squiggle without the equal sign. Did I not show you that last week? Oh, I'm sorry. So on a keyboard, it's called a tilde. But in mathematics, that's the sign for similarity. So we don't have to write these things are similar to each other. We can just write this thing and then a little squiggle and then the other thing. So that's our abbreviation. I apologize if I didn't show you that before. Yeah, don't you love how mathematicians are lazy about writing out words so we come up with symbols for everything? Now, Alex, you said a second ago, you said the equals with the squiggle on top of it. What is the equals with the squiggle on top of it? Congruent. And congruent means two different things. I'm glad you said this because this is important. Congruent means two different things. If two shapes are congruent, then they are the same what and same what? Same size and same shape. Similar means just the same shape, right? And I think this is kind of interesting that they chose these symbols because this is the same shape part of congruent, right? And the equals represents the same size part of congruent. Similar doesn't have the same size, just the same shape. You see how it's kind of part of the congruent thing? Mm. Because there wasn't a whole number. Yeah. Yeah. So that illustrates it's really easy to look at two things and be like, it doesn't seem like they're similar. you got to check the fraction. And I'm going to show you some really tricky problems later on that the textbook's going to throw your way, where they don't even draw things that are the right shape. Okay, so I'll tell you what I mean in a second. Well, I'll show you if you're curious. On a later textbook problem, they're going to tell you that this is a rectangle and this is 2 and that's 6. They're going to draw a picture that looks like a square, and they're going to tell you that that's 2 and that's 6. And you're going to be like, that doesn't look like it's right because this should be 3 times as long as this. But you're going to say, okay, well, it's just bad art. This is 6 and this is 2. You trust the numbers, not your eyeballs. Okay. No, they're going to force you to go based off of the facts and not what your eyeballs are telling you. Okay. They're going to challenge you to use the facts and not your visual perception. Okay. I think you guys did a great job with that. Let's move on and practice how to use this in reverse. So again, this is out of the book, but you don't need to open up your textbook. I'll draw it for you. It's a really simple picture. This is going to be number 25. Let's go ahead and label it. Part A, it's another couple of rectangles. One's a little bit bigger than the other one. And we are told as part of this problem is that they are similar. So this time they're telling us they're similar. And we have to use that to find out some information about these. And the information that's given to us is that this is 2, this is 6, this is 4, and they're going to ask us to find the value of this one. I'm going to give you a little warning here. I know that many of you are going to look at this problem and you're going to be able to tell me what X is without showing any work at all, because this is a pretty simple problem. Now, you might not be able to do that just yet. And actually, if you can't, I think you're probably in better shape. So I'm going to show you how to set up an equation and solve to figure out what X is. But if some of you are looking at this picture and you think you already know what X is without showing any work, that's great. You still need to be able to set up an equation and solve it, okay? Not just because I'm trying to be mean and make you show extra work, but because you can trust me on this. When we do the test, you are not going to be able to do the problem in your head, okay? It will not be nearly this simple. Now, the thing that makes this simple is that probably many of you can look at these two sides and tell me what the scale factor is. What is the scale? What are we multiplying by to go from here? So 2 times 2 is 4. So if I go 6 times 2, that should give me this one, right? And most of you can do 6 times 2 in your head and tell me that X is going to be what? X is going to end up being 12. However, on the test, this isn't going to be 2 and 4. It's going to be 2.7 and 4.95. Okay? And you're not going to be able to do that in your head. So you need to know how to set up and solve an equation. So even though we already know what the answer to this is, bear with me. We are going to set up an equation and solve. So because they're similar, we know that if we create 2 ratios out of our sides, those 2 ratios have to be the same, right? They have to be equal to each other. That's what similar means. Part of similar is that ratios or the sides are in proportion, which means the fractions are equal. I'll get to you in just a sec, okay? Let me finish this up and then I'll come back to you, okay? All right, so I want to set up a fraction. And I know I need to solve for X, so I'm going to go ahead and get X in this first fraction. Do you guys want to put X on the top or bottom of this first fraction? Bottom? Okay. So we are choosing to put, this time we're putting the big shape that goes on the bottom. I'm going to label that because that's where I tend to make mistakes. I want to be consistent when I set up my 2 triangles or my two fractions. So X matches up with 6. So I'm going to put a 6 up here. And then I need to take my other 2 sides, the 4 and the 2. They should make another fraction. So I'm going to make the fraction with the 4 and 2. Now be consistent. We chose to put the bigger shape on the bottom here. So we need the bigger shape on the bottom here too. So what goes on the bottom here, the 4 or the 2? The 4 is from the bigger shape. It should go on the bottom. And the 2 should go up here. So to solve this, actually, wait, before we solve this, I'm going to double check. Okay. I'm going to tell you this. You guys are going to find setting these things up easy and solving them easy. But probably every single one of you is going to make a mistake at some point, whether it's on the test or the homework, where you take one of these fractions and you flip them. You're going to get a wrong answer. Okay. So let's double check. We got 6 and x, they're in the same fraction. 2 and 4, they're in the same fraction. In this fraction, we put the bigger one on the bottom. X is bigger on the bottom. In this fraction, we also put the bigger one on the bottom. So I'm being consistent. I know my equation's good. So I would always double check. All right, now it's time to cross multiply. 2 times x is just 2x equals, and 6 times 4, I'm going to go ahead and write that out. Probably wouldn't write that step down on the homework problem, but this is notes, and we like to have lots of steps in our notes. So 2x equals 6 times 4 is 24. And then one step of algebra to solve that. What are you going to do on both sides? Divide by 2. You guys are awesome. Dividing by 2, 24 divided by 2 gets me 12. And we already do that. But that's all right. Okay. Thanks for your patience. Did you have a question?
No.
Oh. Oh, you were going to give me the equation? Awesome. I'm going to ask you to do the same thing on the next one. So I'm going to call on you on the next one to give me an equation. All right. And I'm going to give you a little spoiler. On the next one, there are 4 different equations you could write.
Yay.
All right. So I'm going to challenge you to give me one, and then I might challenge you to come back and give me another one. Okay. All right. Let's do part B. I want you to have a look at part B. I've got it up on the screen here. Now, this one's a little tricky. Can you guys see that okay? If you want to open up your own book, this is on page 156. But if you can see this okay, that's fine. Just look up at the screen. What's tricky about this problem is that these 2 shapes are not turned the same direction. Agreed? They're going to start throwing, this is the first level of difficulty they're going to start throwing at you. They're going to give you 2 shapes that are one of them's been flipped around, one of them's been reflected or rotated or something. This looks like one of them's been rotated. So here's my strategy for dealing with this. I'm going to draw the first shape on my paper. Go ahead and copy this down onto your own paper. And it doesn't have to be perfect. It is a weird looking pentagon. And they have X and 4. And there's a couple of 90-degree angles, and then this arc. I don't know why they marked those. Yes, yeah. All right, now, when I draw my second one, I'm not going to draw it so it looks like this. I'm actually going to flip it over so it's orientated the same direction as this one. So it's easy to do with my textbook. I'm actually going to physically flip my textbook over. And when I draw the one with the 3 and the 6, they're upside down now. I'm not going to draw them upside down, but I'm going to draw it so it's the same shape as I already have. So it matches up. So next to this, I'm going to draw a smaller one that looks the same now because I flipped it over to match. And this is going to help me get things properly lined up when I go to put them into my ratios. Okay. My challenge for you is, could you please set me up a proportion that you could use to solve for X? And don't solve it just yet, just set it up. And I'm going to raise the bar a little bit for those who are up for an extra challenge. If you can write one proportion, see if you can write me a different one that would also work. And if you can do 2, see if you can do 3. And if you can do 3, see if you can do 4. Okay, I'm going to tell you that I can write 8 different equations that will work for this. See if you can get 2 or 3 or 4 though. I'm a pro. I've been doing this forever. That would be different. That would be different, yeah. Just kind of flipping which goes on the top and what goes on the bottom. That's one way you could change it. So go ahead and write me one equation. Don't just wait for me to do it so you can copy it. I need you to try it on your own. If you get it wrong, that's okay. But I want you to try it. I'll give you a hint. When you start filling in sides, decide whether you want to have the bigger shape or the smaller shape on top. And make yourself a little label. Make sure that happens in both of your fractions. Okay, so if you decide to go with the big shape on top, make yourself a little note that you're going to put the big shape on the top. And then make sure you do that in both fractions. You gotta be consistent with these. Give it a try. Let me know if you're having any trouble. Don't worry about solving it just yet. I want you to try and write me as many different equations as you can. Anybody got 2 already? Anybody got 3 already? Anybody got 4? 5? Oh, wow. Okay. Pretty good. You should have at least 1. I definitely want you to have one that you're feeling confident in. Maybe a second one. If you don't have a second one yet, here's a hint for you. Do the same thing, but instead of putting the big one on the top, put the small one on the top. Or if you already did one with the small one on the top, try rewriting it so that the bigger ones are on the top. So see if you can at least write me 2 different proportions. All right, I'm going to ask for some volunteers, and if you're willing to volunteer, just raise your hand. Can I get somebody to give me one proportion, one equation that has the big values on the top? Alex, you got one that's got the big values on the top? Yeah. Go for it. Let's stick with the values that are in the picture. I love what you did there. I think that's really awesome. Did you guys hear what Alex said? Actually, I'm going to write this down. I'm going to write it down up here because it's a little bit more advanced than I want to get after right now. Alex said 2x over 12 equals, did you say 8 over 6? So you basically just doubled each of these things to create a new equation. I like that. That's thinking outside the box. I asked you to write a different form of the equation and that would work. You just basically doubled everything. Can you give me one that only has x, 4, 6, and 3 in it though? X over 6 equals 4 over 3. How many people had that equation on their paper? Anybody else have that one? A few other people did. Great. Looking for another one? Have you had your hand up a second ago? Do you have another one for me? Six over x equals 3 over 4. Anybody else have that one? That's basically the same thing, but we flipped both of the fractions, didn't we? Instead of putting the big side on the top, we put the smaller one on the top. Anybody have another one? Somebody different? I know, I'm going to call on you in a second, but I want to hear from somebody. Oh, so what do you got? You had 3. I'm going to put this one here. 3 over 4 equals 6 over x, which looks a lot like this. We just flipped the 2 sides of the equation, but that is different. I like it. Do you have another, Alex? X over 6, which is the same as this, but just flipped around. Awesome. I got some more for you. No, this is going to look a little bit wacky to you, but check it out. 4 over x Now I'm going a little bit weird here because in all of these I was using matching sides, but here I'm doing a fraction from the same shape. Does anybody want to guess what my second fraction would need to be so that I match up with 4 over x? What do you think it's going to be? 3 over 6. Do you believe me that that's going to work? You don't believe me? I'm going to prove that it's going to work in a second. But that would totally work. Yeah. I could also do, well, I could do x over 4. What would I need over here if I did x over 4? So x over 4 equals 6 over 3. That would work also. Now, some of my students really don't like this style of equation. But some of my students find this easier to see than these ones. So I wanted to show you. So if you're comfortable with this, you're like, I'm not so sure about that. That's fine. These will get you by as long as you're good with one form of these equations. Now they're all going to work because if I cross multiply, what am I going to get? 3 times x is 3x equals 6 times 4 is 24. All of these are going to give us the same thing. We still have a 3x here and 6 times 4 is 24, right? We still have a 3x here and 6 times 4 is 24. We have a 3x here, 6 times 4 is 24. Even in these wacky ones that I did, 3x and 24. So no matter which of these we choose, we're still going to end up with the same next step, 3x equals 24. And then we just have one more step to divide. Let's divide it on both sides by 3 and get our final answer, x equals 6. How about 8? Thank you. Oh my mental math has just been all over the place today. I appreciate you guys correcting. Thank you. Okay. Are we feeling okay so far? Are you guys ready to move on to the thing that seems really easy, but is really easy to screw up? Let's do this thing. Yes? All right. All right. So again, I want you to be careful about this. I'm going to show you this, and you're going to be like, oh, this is so simple. And then I'm going to show you where it gets a little bit tricky. All right. I am moving on to the next section, and you don't need your book out just yet. In fact, I encourage you not to have your book out, but I'm just going to write down on this number 37 in case you wanted to go back and look at the actual problem later on. This is number 37. I'm going to modify this slightly also, but draw for me a couple of right triangles. One of them is going to be bigger than the other. And we need to mark some angles. So let's put a box for a right angle. I'm going to do a single tick up here and here. I'm going to do a double tick here and here. And these triangles, they're gonna get names. So we need some letters. Make sure your letters are capital letters. When we name points, they need to be capital letters. So we got A, B, C, and Z, X, Y. All right, and our goal here is the second part of our learning target, which is to write a similarity statement. So I'm not going to write a whole bunch of notes for you on what a similarity statement is. We're just going to look at some examples of it. Okay. So a similarity statement is kind of like an equation, but there's no equal sign. We're going to use just the squiggle for similarity. And it's going to be for two triangles. So we're going to name our two triangles. So triangle something is similar to triangle something. When we name a triangle, we just give the 3 letters that are in the triangle. But here's the thing, when we name a triangle, we can put those 3 letters in any order we want. All right, so you get a little bit of creative freedom when you're picking your letters. So I'm going to call on Russell. Would you be willing to name this triangle for me? You got several different options here. You want to go for ABC? All right, let's do it. I like it. That's probably what I would do too. But we do recognize it could be something else, right? Like what? Give me another option. If we didn't want to call it ABC, what's another name we could have used for it? CBA. Or what's another name? BCA or CAB or CBA. So there's lots of different options for it. It's got to have the 3 vertices in it. It's got to have those 3 letters in it, but it doesn't really matter what order we put them in. Okay. However, here's the thing about a similarity statement. This is the most important thing, so don't miss this. Once we pick the order for the first one, the second one has to match the same order. It's got to match. Okay. So once I've chosen that this one's going to be called ABC, then I'm stuck. This has to be in the right order. So I want you to look for me at A. A is this point right up here. In my other triangle, which point corresponds to A? Z. Z is the other one that has the angle with the single tick mark. Since Russell chose for A to come first here, then we have to put Z first over here. All right, likewise, since Russell chose for B to come second, what's got to come second from our second triangle? X has, because B is the 90-degree angle and X is also the 90-degree angle. So it's got to come second. And then by process of elimination, all we have left here is Y, but Y does match up with C. So that's the weird thing about similarity statements, is that they've got to be in the correct order. Whatever order you choose for the first one, the second one has to match. Okay, so if I wrote this for an answer on a test, is that correct? No, because A does not match up with X. A and X are different parts of the triangles. So that's wrong. However, I could write in a similarity statement that had X, Y, Z in it. I challenge you, don't shout out answers, let everybody get a chance to look. I challenge you to figure out what my first triangle would need to be called so that X, Y, Z would be correct for the second. So see if you can work that out and write it down on your own paper. So if we want X to come first here, then think what needs to come first in my other triangle that would match up with X. If we want Y to come first or come second, then what needs to come second? If we want Z to come last, what needs to come last? All right, if you're able to get this right, then you really understand how similarity statements work. So X matches up with P, Y matches up with C, Z matches up with A. How'd you do? You get it? You feeling good about it? Show me your thumb meter. Similarity statements. How you feeling about it? Okay, this is pretty typical. As I show this to people, and they're like, "Oh yeah, this is easy. You just gotta get them in the right order, right?" Okay, yes, but it gets really easy to make a mistake. Okay, and so I warned you that was going to happen. I'm going to show you where those mistakes are going to happen next. Okay, so this is also from 37, but I'm changing it. I do not want you looking at the book for this. I want you to draw my version. Very similar, but I'm going to make it hard because you guys can handle it because you're awesome. Here's 2 triangles. We've got triangle dog, D-O-G, and you guessed it. And let me give you some lengths here. Now, before we start writing similarity statements, I want to verify that these two triangles are similar. Okay, so I'll tell you that the angles all match. You verify the sides for me. We need 3 fractions, right? Because we got 3 different sides. And those fractions all have to come out equal. Now, this is where it gets tricky. If I want to put 8 in the top of this fraction, what's the side that matches up with 8? Is it 10 or is it 16? Or is it 18?
Okay, wait, what?
What do you mean they're all equal? I'm not sure what you mean by all equal. Well, no, I'm saying that all the pairs of angles are equal. All the angles are not equal. These are both scalene triangles, which means they each have 3 different angles. But the 3 different angles in this triangle match up to the 3 different angles in this triangle. But I'm going to tell you that this angle and this angle are not. I need you to be able to tell me based on the side what matches up with the 8. The 8 is here. Why do you think 10? Because it's on the left-hand side, just like the 8 is? Okay, here's the thing. This is where this gets tricky. You can't trust that. You can't trust that. Russell, what do you think?
Well, I was going to say the 16 because in order for it to have everything to be proportional, the 5 has to go to 10, it has to go to 16, 9 has to go to 18. So it looks like 10 is a reflection.
So you think the 16? All right. So I'm going to give you the cheat code for this, okay? If you can remember this, this is going to get you out of a lot of trouble, okay? Number 1, you got to remember to do this. You can't just say these are on the left-hand side, so they match. These are on the bottom, so they match. That doesn't work. Okay, remember how I told you this is going to seem easy at first, and then it's going to get tricky. This is the tricky part. Here's your cheat code, okay? Look at your 2 shapes and find the smallest side in both shapes. What is the smallest side in this one? 5. And what is the smallest side in this one? 10. 5 and 10 are going to go together because they are both the smallest sides. So one of my fractions is going to be 5 and 10. Now I'll do the same thing, but find me the biggest side in each of the shapes. Biggest over here is 9, and biggest over here is 18. So 9 and 18 are going to go together. And then the mama bear side, the middle side, those are going to match also. So Russell, you were correct. 16 is going to match up with the 8. So match the big side with the big side, small side with the small side, medium side with the medium side. You got to look at the numbers, okay? So this is what I was telling you. These are going to get tricky. Now, I'm being honest with you here. I'm pushing you guys a little bit further right now because that's the actual picture in the book. And if you saw that picture, you'd probably be able to tell me that the 5 and the 10 went together because they're clearly the smaller sides, right? Visually, you can see that. But later on, we're going to get pictures that don't show actually how big the sides are. We have to use the numbers. Okay, now let's check this. 8 over 16 is the same as what? That's the same as 1/2. And 5 over 10 is also 1/2. And 9 over 18 is also 1/2. So they are similar. Agreed? All right, so here's the tricky part. The next tricky part. I want a similarity statement. Let's go with triangle dog. All right, now we know that these things don't match up to each other, and we can't just say D is in the lower left, so it matches up with A, because that didn't work for us last time, right? So you ready for cheat code number 2? Don't miss this. It's going to make your life easier. When you're comparing them, I want you to look at the side that's across from it. Notice that D is across from the smallest side, right? D is across from the smallest side. Which letter is across from the smallest side in this triangle? C is across from the smallest side. So we want C to match up with D in our similarity statements. You see how that works? So you want to look at the side that's across from it. That's the easiest way for me. I have some students that have figured out some other ways to do it, but a student showed me this once and I was like, oh, that's it. That's what I'm going with for the rest of my career. All right, what's the biggest? Sorry. O is right here, and I'm looking at O happens to be across from 9. 9's the biggest side, isn't it? What's across from the biggest side over here? T is across from the biggest side, so T must be next. And once I got C and T, then all I have left is A. It must be my last one, my process of elimination. CTA. Man, I wanted it to be cat. Didn't work out. All right, do you see what I was warning you about at the beginning of class? This seems like it'd be really easy, but then like, oh wait, we gotta be real careful because you can screw these up super easy. Question? Great question. Question was, why are we doing small, big, medium instead of small, medium, big, or big, medium, small? Anybody got an answer for that? What do you think? Because that's how I wrote. That's what I felt like writing. So, Alex, to answer your question, if you want to do small, medium, big, if you want to do it that way, you can. Actually, I think that's probably a good strategy to make sure that you get them both in the same order, right? If you purposely start with the smallest and work your way up to the biggest for the first one, and then you just follow that same pattern for the second one, boom, you know you're going to be in the right order. So great question, and I think that leads us to a good strategy. All right, now I really wanted this to be similar to triangle CAT, and we could call this CAT. My challenge for you, could you figure out what I would have to call the first triangle so that it matches up with CAT? All right, again, this is kind of a test to see where you're at right now. If you're feeling confident about this, that means that you're really understanding. If you're a little bit like, oh, I'm not too sure, this would be a great time to ask a question. Got it? Jack, you got it? So again, I would be looking at C. I will be looking at what's across from C, and across from C is the smallest side. So I'd want to match up smallest over here, which is D. So C matched up with D. So you should have started with D. And then A is across from the medium side. Medium side over here was across from G. And then that leaves O. Did you get DGO? Right. We have one more example, we'll be all done. You guys are doing awesome. Thanks for your patience. And it is 38. Copy this down for me. You don't need to open your book. I should have just told you not to bother with the books. Triangle, nope. It's similar to triangle XYZ. Let me draw these two triangles for you. I was trying to be a pen up there. Sorry. Recentering. Now, I've drawn them so they look basically the same size again. This is W, this is 12, this is 3, 4, and 5. You gotta find W. Oh boy. Now this is gonna get tricky. We need to write an equation that has two fractions in it. And we're solving for W here, so we got to get W into our equation someplace. The question is, does W match up with the 3 or the 4 or the 5? Now, if I asked you at the beginning of class, you would have said the 5, right? Because they're both on the bottom. But now you know that I could have shuffled this around or spun it or flipped it. So we got to be careful about that. So I want you to use the same thought process we did a second ago. If I'm trying to match up W, look at what W is across from. What's W across from? X. In which letter over here matches up with X? Don't forget, you've got a similarity statement up top that tells you exactly what matches up with what. What matches up with X? We can tell by our similarity statement that X and N have to match up, right? Similarity statement has to be in the correct order, right? So we know that X and N match up. So here's my X and here's my N. So if W is across from X, then W must match up with 5. Turns out that it did. It is 5. You know how that works? Now we need another number over here. What am I going to put in the top of this one? I only got one choice for that. It's got to be the 12, right? Because it's got to be from the same shape. Now, what's going to match up with the 12? It's not the 5. It's either the 3 or the 4. You think it's the 3 or is it the 4? Why are you saying 3, Jacob? So are you looking at the Y? Are you noticing that 12 is across from Y? And that Y matches up with what in our similarity statements? Y matches up with O. And O is across from the 3. So that's where you're getting the 3 from. Oh boy, that's tricky, isn't it? That's a little bit more challenging. Go ahead and solve that for me. And then that'll be it for our notes for today. Now, I know that you guys are going to have some questions about this. We covered a lot of ground today. This was actually one of the longer days of notes we've had. I appreciate you guys sticking with me as we go through two lessons. We were not going to be doing this every day from here on out, okay? So I know you're going to have some questions. If you're still feeling a little confused, that's okay. I want you to ask some questions during our work time here. I don't think I'm going to have time to check your homework, so I'll have to do it next time. I'll make sure to carve out some time for that, though. 5 times 12 is 60, by the way. So I think W is 20. All right, so our big concepts today were setting up equations like this, and you guys got pretty comfortable doing that, but then I changed everything on you and I started spinning stuff around. So the other big concept is the idea of a similarity statement. If we're writing a similarity statement, we got to make sure that everything matches up in the correct order. So we've got to look at the sides and use the trick that I showed you. The biggest help that you're going to find is look at the side that's across from each angle. So when you're trying to match D, look at what's across from D. It's the smallest. Find the smallest over here. That's what's going to match up with it. When we're writing equations, sometimes we have to look at the similarity statement to figure out what goes in the same fraction with particular size. Right? This is going to take some practice before all of us are feeling really confident. So if you're kind of not 200%, you're going to see 1 or 2 problems like this in your homework. I want you to do the best you can. I want you to come in and ask some questions on Thursday. We'll go over them. I promise you on Thursday we'll have some time in class for you guys to practice on your own and get some help, okay? All right, folks, thank you so much for your attention. I'll go ahead and put the homework assignment back up.